Good afternoon. How is everyone doing? Just grabbed some snacks, relaxed. So many snacks. And with that, we are good to go and talk about some activity. We did the full activity last time, so I might just do like some review and some troubleshooting. We do have a really cool app created by, I gotta make sure I'm not getting DMCA'd on every video I show this on. Let me go to my YouTube studio and see if, what's the group that plays the song? Foreigner? Who plays Final Countdown? Journey? I don't know. Okay, we haven't gotten DMCA'd yet for playing it. That's good. No DMCAs. So if you're in the chat right now, let me know. We're going over and looking at different things. New mention on 475. It's 5D on 72. Asking for comments. So how do you know it's been a while if not what's asking for? Which one's 5D again? Maybe go look at, here it is. 5D. I'll answer this question. Let me start right here. Intervals are made for individuals in a regression model. We can use the predict function for this on an LM. And let me know if you have additional questions. Let me look back at the 320. Let's see who's in the chat. Ella, good to see you here. Ella, what are you wondering about? Let me know, Ella. We've been listening to that song so much today. There we go, chill out music. So which ones are you wondering about, Ella, or what are you working on? Let me know. Are you working on any particular problems on the activity? I think we actually, like I said, did the full activity last time. So let me get 320 pulled up right here. And we got the R basics. Let's go look at the activity. We have activity 1 due very, very soon. Activity 2, for loops. Ooh, we need to do some for loops. Okay. We need to jump in here to some for loops. And that activity, how do on the 11th? The 11th. The 11th is Friday. Let me move this to Monday. Probably a lot of people are going to do it on Monday. Okay. So let's go ahead and grab the for loops right here. I just opened up the for loop activity. Oh, for loop. Yes. Question number 2. James, great to see you here. If there's any ones I'm working through activity, I'll only finish the first one. Awesome. So let's do some for loops. Question number 2. Let me go grab that. Just released it right here. And for loops, activity number 2. James, thank you for swinging by. Okay, got the notes. And let's go right here. Take the timestamp. Activity 2. For loops, question 2. Let's go take a look at this. And question number 2. Okay, let's go take a look at for loops. So we've got a data file here, which is an R file. And then we got a programming file right here, a practice file. No solutions yet. Let's go ahead and download these and get started right here. Now, the RMD is the R Markdown file, which allows us to create all the great output. We're going to decrease font size here just a little bit. It says solutions, but it shouldn't have them in here. Oh, it's a trick. It's a trick. Question number 2 says the following. Basic for loop. The infinite sequence 1 plus 1/2 plus 1/4 plus 1/8 plus 1/6 plus 1 over 2 raised to the ith can be shown as exactly 2. So that's what it's going to be. It's shown when we get the sum, it's exactly 2. With this, verify this seems reasonable by using the for loop. A vector x whose elements are the first 50 values of this series. Then print to the screen the quantity 2 minus the sum of these elements, which should be really, really close to 0. Okay, cool. And they're showing us how to kind of do all this. But here's the thing. How do we make a for loop? So when it comes to making a for loop, there are 3 components to a for loop. And I like to make a basic for loop to start. So when you make a for loop, what 3 letters do you type to make a for loop to start, James? When you make a for loop in R, what should you type to make a for loop? You should think of SpongeBob. F is for friends who, well, that's function. We'll do functions here a little bit. But when we make a for loop, what do you think I'm going to type to make a for loop? What do you think I'll type to start out by making my for loop? Now, this is the best thing to do. You're about to see what's called a snippet, which is going to help us write code. But you got it right there. That's worth some points in the chat. We're going to type FOR and we get the snippet. Now, the snippet is basically like a partial bit of code. Oh my gosh, my volume was lowered. What did I do? The snippet is a partial bit of code, and it allows us to get this right here. Marshall and James, great to see you right here. Some points in the chat. So we have right here the basics of a for loop. So we have a variable, and we have a vector, and then we have what is called the skeleton. So we have to know what these things are to utilize them. Now, the skeleton is the code that runs every time the for loop runs. The variable is going to be a placeholder. This is just a placeholder thing. It's just going to hold the place for us. And the vector is what the variable goes through. So like take notes, skeleton, the code that runs. Variable, placeholder, can be anything. Can my variable be called Brian? Yes or no? In the chat, can my variable be called Brian? Read the note on variable. Placeholder can be called anything. Can my variable be called Brian? Placeholder can be called anything. You probably won't want to call them Brian, or you can if you want. Everything in your Rusty Smashers is called Brian. Can the variable, which is a placeholder, yes, it can. James, great answer right there. Yes, it can. It can be anything. It can be anything we want. So then we have what is the vector. What's the vector? The vector values the placeholder will take on when the code runs. Now let's put an indent. Also controls how many times the loop runs. Really good notes to have right here. The vector is the values the code will take on. I want you to think of this first. What does this code do right here? What does that code do? Just explain to me in words. 52 does what? What does line 52 do? So what does line 52 do? Just be like, oh, line 52 is going to do this. That's what line 52 does. Nothing too complicated on line 52. Just what is line 52 going to do? Just it pretty much does what it says. You're like, okay, it says this. So it's probably going to do that. Don't go too crazy. So if I run that line, it'll do what? What do you think that line will do? Kind of, it's going to print to the page Brian. Exactly right there. It's going to print Brian. We got another 2 seconds. Oops. Make sure I get the right individual right here. Hide user on channel. Good job. So it's going to print Brian, right? Boom. Prints Brian. Let's try something different. Let's say print object Brian. Now here's what happens. So take a look, and I'm going to show you visually what you're about to see happen. Visually, what's going to happen here is when I run this, let's go to a word sheet. What my loop does is it's going to store into Brian. This will help for some of the homework. It's going to store into Brian 1. And then my loop will, oh, it could go, yeah, sure. And then my loop will print Brian. I prefer to go the other. Brian is going to have 1 stored into it, and then it's going to print Brian. And then when it gets back around here to the top, what will it do next? After it puts 1 into Brian and then prints Brian, what will it do next? So it's going to store 1 into Brian and then print Brian. And then it'll do what next? So it's going to store 1 into Brian, print Brian. Then it'll do what? So when it goes back around here to the top, it's going to then do what? So it's back up here at the top after it ran that. So what's it going to do up here then? It stored 1 into Brian, then printed Brian, that loops back up. It'll loop. So what would be the next step? After it stores 1 into Brian, here's what the code's doing. It says object Brian store 1 into it. That's what it's doing. Oh my gosh. And it'll store 2 into Brian. So it's going to print Brian then. And then it's going to print object Brian. And then it loops back to the top. I don't even know how to spell my name. And then it's going to store into object Brian. This is why I don't ever write anything. I just type things. It stores 2. And then what will it do after it stores 2 into Brian? It'll print Brian. And then it'll store 3 into Brian. Then it'll print Brian. Then it'll store 4 into Brian. Then print Brian. Then store 5 into Brian. Print Brian. So what's my code going to do right here? Does anyone know what? Can anyone explain what this code will do? Remember, Brian's just a placeholder. For all intents and purposes, it could just be Darren. It's just a placeholder. What does this code do when I run it? It's going to store 1 into Darren, print Darren. Store 2 into Darren, print Darren. Store 3 into Darren, print Darren. And I'll call this. Cool, better. Store 1 into number. It won't print Brian 10 times. Close, Marshall, good guess. But Brian is 1. Brian is 2. But what's it printing? It's going to store 1 into number, print number. So whatever is in number will be printed. Store 2 into number, print number. Store 3 into number, print number. It might make more sense if I show it to you this way. What will this code do right here? Store 1 into number, print number. Store 2 into number, print number. Store 3 into number, print number. Store 4 into number, print number. Store 5 into number, print number. It'll do what? You're really close. If you have this understanding, it makes a lot more sense when we think about what they're doing. So what is it going to do right here? Right about there. The first one did that. Great job, Marshall, right there. The first one did that, and I changed the example to be smaller. I'm just rewriting the vector. I'll write the full vector we did. And so if we run this, it prints the numbers 1 through 10. Because it stores 1 into number, prints number. Stores 2 into number, prints number. Stores 3 into number, prints number. Stores 4 into number, prints number. Does that make sense? Stores 5 into number, prints number. How about this, though? Be careful. I'm trying to trick you. What does my skeleton, or we could do it this way. Yeah, we'll make it look similar. This is a trick question now. What does my skeleton do? It prints the what, Brian? And then we're going to solve this problem right here. My skeleton right now prints the what, Brian? Not the object, Brian. My skeleton right now, tell by the color coding, is not printing the object, Brian, or the placeholder variable, which is an object. It's not printing the placeholder variable. It's doing what? It's printing the what right here. So because I put it in quotes, good practice on reviewing it, it's printing the character Brian. So now this code won't print 1 through 10, which Brian has 1 stored into it, Brian has 2 stored into it. It's just printing Brian every time. It's just going to print Brian 10 times. But if I remove this, it sees the object Brian and prints 1 through 10, or, well, I just ran that. Prints 1 through 10 when we run the loop. So that was printing the character Brian if we put it in quotes. And, got to run the loop. So that prints the character Brian 10 times. This will go to the object Brian, which is just a placeholder for what is stored into Brian. And we could make it smaller to look at a smaller example. So that is how the loops work. So we'll use this knowledge right here to understand how the loop is working. And let's use our example right here to think about this. What we need to do is we need to write this right here. And I think the confusing part about this is when you see 1 plus 1/2 plus all these right here, and we want to do the first 50 elements, the first one's not expressed properly. For 100 points, who knows how to express 1 like the other ones are being expressed as a fraction? I'm asking kind of a very simple but seems complicated question. Let's express 1 as a fraction. So how could we express 1 like 1/2 as a fraction, 1/4 as a fraction? Great, Connor. Perfect answer. Let's express this as 1/1. It's great. I'm throwing more points. People are following along perfectly. So now going down here, let's go 1/1, and then let's take this right here and raise it to that. That is still 1. What we need to do, ooh, no, we don't want to do that. We want to go right here. We need to square it. Oh, I see. Okay. That's interesting. Such a weird problem. That's such a weird way to express it. It's the way I'm thinking of solving it right now. What is anything raised to the 0 power? What is anything raised to the 0 power? 2 raised to the 0 is what? Such a mathy problem. 2 raised to the 0 is what? 2 raised to the 0 is what? 2 raised to the 0 is 1. So that's just... So anything raised to the 0 is 1. Don't worry, Connor. Don't worry. 50 points right there. Anything raised to the 0 is 1. So we basically solved 1/1 again. So many ways to express this, but guess what? What is 2 raised to 1? It's 1/2. And what is 2 raised to 2? It's a 4, which is 1/4. Guess what we just did right here? We just created a what? Which of these 3 things did Brian just kind of create? If you notice right here, I'm just changing this value. Now, don't worry about the value I'm changing. But maybe if I just put a placeholder here, like for value, what do you think I just created of the 3 things? Did I create a skeleton? Do I create a variable or a vector? Now, it does have other components in it, but this whole thing right here will be the what of my code, because I need to do it multiple times, it sounds like to me. So I need to do this multiple times. I created the skeleton. So the skeleton is the code that repeats right here. Let's rewrite a for loop here. We just created a skeleton. Let's put the skeleton in here. So where should value go? Value is a placeholder for what changes. What value am I raising it to? Or I could say raise to or value. It doesn't matter what I call it. But where will that go on here? Is that the vector it goes through, or is that the placeholder? I've got notes down here on the bottom to help us out. Which one of these is it? Is value going to be the variable or the vector? So it's just a placeholder that will change when I run the code. So it's just a placeholder that will change when I run the code. Which of these? Does this sound like, is value a placeholder? Or which one of these is the placeholder? Let's see what people say. Oh, I'm on top, chat. Everyone's probably answering. Variable, great job, Ella, right there. More points in the chat. It's going to be right here, the variable. Now, this is the tough part. We're not going from 1 to 50. We're going from 0 to 49, and let me explain why. 0 to 49 has a length of 50 elements because you're basically going 1 to 50 but shifting it backwards. The reason we're starting at 0 is because we're doing 2 raised to the 0 power. Does that make sense? 2 raised to the 0 power is 1, so we're doing 1 over 1, 1 over 2, 1 over 4, 1 over 8, 1 over 16, and so on. So this right here, if we do this, we could actually confirm it's working by going to print and print these values right here. We're just going to confirm this is working. And there, right there, we can see it, and it starts to get pretty wacky pretty quick, but you can see the values printed to the screen. Does that make sense on what we're seeing? We're seeing 1/2, 1/4, 1/8, 1/16, 1/32, and so on and so on and so on. We've just created this series of numbers, and we confirmed it's working by printing it. So now, whom elements are the first 50 of the series, then print to the screen the quantity 2 minus the sum of the elements. Okay, so now what we have to do, this is the fun part. This is the fun part. My brain's like pausing for a moment to think about it. What we want to do is we want to store this. Okay. So when we store this right here, let's call vector, or let's say answer 2, and create a blank vector. This is the tough part, and I think this is where people will get lost on it. Don't tell me if you're not lost right here. Okay. When you store into something, you must first create it. Before storing into something, create it. What is inside of answer 2 right now? What is inside of answer 2? And just take a look. It doesn't even have positions. So what is inside of answer 2 right now? What do you see? Look up there. What does this do? Look over here. What is inside of answer 2 right now? So by doing a blank vector, which is a blank vector, what is inside? Nothing. Nothing's, I just created a space. I just gave you a box. There's not even positions in the box. I said, here's a box to put something in. So we haven't stored into it yet. So we're going to do the same process over here. And this is the really tough part, I think, that might confuse people. Let me ask you this right now. And this is why we're not coding in Python for the moment. When I first run my code, what will value become? So when you first run your code, what will value become? So when I run the for loop, using our knowledge from earlier, value will become what? It'll become the first element of the vector over there. So what will value become? What will value become? When I first run my code, it'll become 0. We don't index on 0 in R. We index on what? So what do you think? I shouldn't do value right here. I'm very close to the answer. So I shouldn't say store into position value. I want to store into position what? Not value, because value is 0 right now. So I remember what we index on. We index on 1. Well, so how could I tell it to? Because if I do 1, that won't change as my code runs, because now it'll store every time now it runs, and I'll show you, it'll overwrite position 1. So by the end, which don't worry, now just that's the last answer. If I say 2, well, it's going to overwrite again, and we're just going to get the same last answer. It just so how about value? But value will be 0 the first time. Value will be 1 the second time. Value will be, oh my gosh, I'm losing it, 2 the third time. But instead of doing, because it's 0, then 1, then 2, then 3, then 4, then 5, so what do you think I should add to value? What do you think I should add to value so the first time it's value, it's actually 1 instead of 0? So the first time it runs, I want it to be 1 instead of 0. So what should I do? Because the first time it runs, it's 0, but I actually want that to be 1. The second time it runs, it's 1, but I actually want that to be 2. The third time it runs, it's 2, but I want that to be 3. So yes, that's it right there, Ella. Exactly. Value plus 1. Does that make sense? Because the first time it runs, it's 0, but I actually want it to be 1. So I'm saying, okay, this becomes 0 the first time it runs, so it stores into position 0 plus 1. The next time it runs, it's the second run of it. And so does this make sense right here? That's probably the toughest part of this one right here. That's the toughest. And guess what? When we run this, answer 2 is now the vector of numbers. There we go. It's the same vector. It's just in like scientific notation, 1 e to the 0 is the answer. So now we've created it. And so with this right here, it says confirm it by doing the sum of the answer minus 2, or 2 minus the sum of the answer. And that's actually just a tiny, tiny fraction. We could continue this out further. Sure, why not? And now it says 0. It's carrying decimals down very, very tiny. So I just made it go even further by giving a ridiculous vector. And now there's such small fractions of decimals. These are tiny, tiny fractions. What's even cooler, watch this. Oh, is it the mass package? Oh, man, that's not fair. Look at that. It doesn't even tell you fractions past 1/1024. We can confirm some of the earlier ones, but we can't confirm later fractions. There's the only fractions we can confirm are to the 11th fraction. The mass package won't tell you fractions that are too small. I don't know why. It just can't figure that out. For some reason, they didn't program it to figure that out. But we have confirmed via the fractions function that we are making the right fractions. 1, 1/2, 1/4, 1/8. And then we confirmed also. So does that make sense right here? This was a tougher problem to start on. Definitely tougher. We might go back and do the first problem now and see an easier one. But this was a pretty good, tough problem. Any questions on this one right now? Thoughts? Pretty tough problem. If you followed along, great job. And if you didn't, we're going to do another one right here. But is there one that people want to cover? I can probably go do the first one because little tougher problem right there, I'd say. I think we'll do this one. Here, let's put a cut in the video. Woo. Let's go do problem 1. Let's go check out some problem 1. Put those questions put those questions in the chat if you got it. That was a tougher problem. I'm like, ooh, tough problem to start. We got a lecture on it tomorrow. I put the activity due Monday for our section. Let's go grab the timestamp. 2450, activity 2, for loops question 1. Okay, let's go check out the first one. A little bit easier, kind of start out with something easier. It wasn't much code right there, but I don't know. Well, let's jump into it. Here we go. So this loads the R environment right here. Make sure if you're doing an r.dat file, that's basically a brain of R. Are there other ones? That's about the maximum difficulty, I'd say. It just depends. There was some decent difficult theory stuff on that. But once again, I want to point out, always code in little bits. Whenever you're stuck, let us know. Like, be like, hey, this doesn't make sense. Because it's all about asking and just getting help and practicing. My best coding students are the ones who ask all the questions. And then they teach me things. They're like, hey, Brian, I found this to answer the question. I'm like, oh, I didn't even know that. So we're going to load in the environment. We should know this loads basically a brain. It's going to load a bunch of stuff. Cool. If it doesn't load, tell us immediately because there might be like files saved in the wrong spot. So down here, we got the basic for loop. Okay. Although setting x to be equal to the sequence of 5, 10, 17, 101 is easy with x stored into 1 plus 1/9 raised to 2 plus 1, write a for loop that defines each element of x one at a time. The ith element of x should be the value of this. Check the first element of x indicated. So here's the thing, Ella. This code right here, and this is what we need to identify. This is the code we're going to repeat a whole bunch of times. So what do you think this code will be? This code right here will be our what? So this is the code we want to repeat a whole bunch of times. This should be our what? This code that we're going to repeat a whole bunch of times will be used as our what? because we're going to somehow, it's going to be our skeleton, right? So check out the first part of this video where we talked about skeletons. Let's bring that back up here so we can have this as reminders so we can practice what the words mean as we talk about them. The skeleton is the code that repeats. Inside of the skeleton will always be a placeholder. The placeholder is what changes inside the skeleton. Notice how this goes through the vector of 1 through 9. So we have the vector of numbers it's going to go through. So let's just call this values or something like that. I usually like to call it like values. So I think you might have this one, because check this one out. This one's a little bit easier. We just created the skeleton. So what are we going to type right now to start out? I think you'll get this because this is a little bit easier one. Not as crazy on what we have to do. What do you think I should type to start making my for loop? Anytime you make a for loop, just start by typing this. Don't type the whole thing. Just type 3 letters, and what should we type to make our for loop? We've identified a skeleton. We've found the vector we're going to use, and we'll take a look. What do you think we should type right now? We could do that. Type 4. Ella, you've already got it. You've already put your... Ella, I think you just literally solved it. And then we just need to store this. Ella's already got this, and then the skeleton goes inside the for loop. There you go right there. You've already got your vector of values it's going to go through. So when this runs, it'll change values from 1, then to 9, then to 2, then to 3, then to 4, then to 5, to 6, 7, 9. And frankly, does it say print it? It defines each element. Oh, so we need to define X. Okay, so what do I need to do, Ella? Remember what we did last time? I need to create a spot. Create a spot to store into X. Okay, how will I create X to store into it? How will I do that? Think about the code to create like an X to store into. Like we need to make something X just to store into it. I need to first create it so it exists. 100%. There we go. Ella, keep it up. You got this. Okay, now I need to store into position 1, then 2, then 3, then 4, then 5, then 6. What will I put before this? Now be careful, but what I need to store into changes. The position I store into changes each time it runs based on store into X position 1, store into X position 2, store into X position 3. So what will go here at the start of this code? You might be like, man, the second problem was way more difficult, because I think you'll get this all. I think you got it. So I want to store into X and then position and then 1, but it has to change. So every time the code runs, it's going to change store into X position 1, then X position 2, then X position 3. So we need to use a placeholder that's going to go through the vector. So how would I write that? Like, what do I need to finish my code right here? So I need to change X and then position and then change what it goes through. You got this. I think we're done. We're just a few characters away from complete. I think Ella's running in the background to double check. Like, yep. Did you run it in the background, Ella, to double check positions of values? The second one was way more difficult. I told you, I was like, second one was a little bit tricky right there. Great job, Marshall, too. Excellent work, both of you right there. And great job. Answer all the questions. Repeat and practice. I think maybe both of you are probably coding in the background, but that's got it. That's it. Not nearly as bad, not nearly as crazy. It's all about making those little bits and understanding what we have to create. If we're going to store into X, we have to create X to do it. Oh, no, you're fine. You're fine. You're doing great. Great practice. So there's the write the basic for loop. Be sure to initialize X. That's what it's talking about right here. When it says initialize X, I just say create it. That's initializing something. Like that's the creating a spot to store into it. Was there a walkthrough? Oh, here's the walkthrough of it. Nice. Might be a walkthrough of this one too. And there's the walkthrough of it. Yeah, so yeah. Let's do another one. Let's knock out another one. Which should we do number 3? Oh, number 3 is really good. Let's go back here. Number 1, pretty easy. Let's do number 3. Okay, number 3. So, if you have one you want to hear, let me know. Activity 2, for loops. Question 3. Let's go check it out right here. For loop over categories. So here's the thing, is we don't have to use numeric vectors. Like, what will this for loop do? Let's say name, and let's say Brian Cat. Oh, yeah, sure, why not? Cat paste You don't have to know how to do this kind of stuff. It's just fun. Hello, I am, and then don't need a space, comma names. Do I know the special character still? I always forget it. \n. Okay, what will this code do right here? Don't worry about the \n. It's a special character that starts a new line. The first time this loop runs, it'll do what? The first time this loop runs, it'll store into names what? The first time this loop runs, and we'll draw it out here visually so we can see in practice, it's just to show we don't need to put numeric stuff in there. We don't need numeric values in loops. So the first time this loop runs, it'll say, okay, names becomes Brian. And then it just runs this code right here. It just runs this code. And then the next time the loop runs, names becomes Darren. And then it runs the code. And then names becomes Emily. How many times will my loop run? How many times will my loop run? It runs the length of the vector. So you can look at the length of the vector. How many times will this loop run? Don't worry about the cat paste. That's just the code that's running. But how many times will this loop run? This loop will run how many times? It'll run 3 times. It's going to say, hello, I am Brian. Then it goes back here, changes names to Darren. Hello, I am Darren. Because it's just a placeholder, whatever it loops through. And then it says, loops here and stores Emily into names. Technically, it stores into not names that store into Emily, but names becomes Emily. And then it runs, hello, I am Emily. So we go right here and we run it and we see, hello, I am Brian. Hello, I am Darren. Hello, I am Emily. And all we're doing right here is noticing is we don't have to use quantities. We can use anything it can loop through. So let's look at what this question wants us to do. Although the aggregate would be much easier, it would be. And it just literally shows you the function, which is such a great function. Find the average tip percentage for each day of the week using a for loop. Okay. So the number one thing to do right here is if we're going to find average tip percentage for each day of the week, we need to first find a tip percentage for a certain day. If I want to find a certain day, I probably want to create a what. So let's write some tasks right here. Oh, it already has it. So how would we get like only Saturday? Great tips right there. How would we get only Saturday? Let's load the data tips as it says, library reg class data tips. If you don't have reg class, make sure to do install.packages reg class only if you don't have reg class installed. How would you only get data on Saturday? How could I only look at Saturday? So if I want to just look at Saturday, I need to probably create a what? I want to just look at Saturday. I'm like, I only want to talk about Saturday. Saturday is the only day I care about. What should I probably do? I want to only look at Saturday. Saturday would be a really interesting day to look at. I probably want to create a what? How would I get only Saturday? I want to go to the tips data set and say, only let me look at Saturday. Subset, Connor, great job. I want to create a subset. So we've got here weekday. And let's see right here. Let's go subset. And we will subset the tips data frame. That does only, don't worry, it's graphics error. And I hate that does that. And then we need to put in conditions, which are going to be a comma. And then we say weekday equals Saturday. Now be careful. I used to not put these in quotes because we're looking for, I know it's a word Saturday, but that's the way it registers the level. If we don't put it in quotes, it would think the object Saturday. But it's saying it understands the first thing is going to be the variable name. And then the second thing, so we're saying the variable weekday is equal to Saturday. It's going to check for logical equals. So if you look right here, the tips data set has 244 rows. Ooh, we didn't get it. I see a bunch of Saturdays. Oh, it's just the row numbers, right? Okay, we're good. It's the original row numbers over there. The fact that it didn't go to 244. But what should I probably do to this object now? Well, we don't have to. Any ideas of what I should do now? Tell me what I should do. I just only got Saturdays. So what should I do right here? I just got Saturday. Lots of ways to do this. I might even do this different ways today, but lots of ways to do this. We just got a subset of Saturday. So what do I want to actually look at for Saturday? We just got a subset for Saturday. I want to look at what variable. It's up here. I'm going to do it a different way than I've ever done it. What do I want to look at right here? Watch how we build this, these little bits. What do we want to look at for Saturday? We want to look at the what variable. Like, we should look at this variable in Saturday, like just for Saturday. What variable are we interested in? say? Tip percentage, exactly. We're going to copy paste that right here. And you actually have to put it in quotes. And I want to point out what I did. I found the column because what I'm doing is identical to doing the following. You could store this as sub. And then it's a subset of just those rows. And then you could go here and get the tip percentage column. Does that make sense, Ella? So what I'm doing is I'm kind of bypassing the step of storing it. And instead of creating the object sub, I'm just putting this right here and getting the same information. So it already is a subset. Like this creates the subset. It's the same thing as if I stored it. And then I'm just grabbing the column out of there. Now here's the really great thing. What could I wrap this in to find my answer? What are we trying to find from this? We just want to find what now? The what of tip percentage, 4-letter word. So I've got a vector of numbers. I probably just want to find the what of that vector. I just want to find the what of that vector now. What do we want to find of that vector now? We've got a vector. We find the what of it now. Average the mean of it, right? Great job, Connor and Ella. Excellent work. More points in the chat. And now tell me this. Watch this. You ready? Can I do it for Friday? Can I do it for Sunday? Can I do it for Thursday? There's only 4 days of the week. Can I do it for all those different days? It kind of looks like I've created my what here. With what I just showed you, it kind of looks like that's maybe the what. With what you saw right there where I'm just changing this, this looks to be the what. It's just not what I'm changing, because that's a different thing. But the code, the whole thing itself, the code that runs, and I'm just changing one thing inside of it, that's going to be my what. Landon, great work right there. More points, Landon. That's part of the loop, the skeleton, right? So let's go right here, and let's type FOR, and then put it inside as the skeleton. But we probably need to choose a what now? Like, what should we probably choose right now? Like, it's not ready to go. We're almost there. We're almost there. We're almost there on this. And then we can do some... Might do a few more extra things. We're almost ready to go on this. We're almost ready to go. What should we do now? We need to do a few more things. Any suggestions? So we've got the... Nothing's changing, though, because we don't have a what right now. Nothing's changing. It's just static code. If I were to run this, it would just do that code each time. It's got to change. Weekday and vector, exactly. So weekday, we actually want to go through the levels of tips weekday. So that's the vector we're going through. These are the values that we want to go through, right? So those are the values that we want to go through. We want to go through Friday, Saturday, Sunday, Thursday. I don't know. They started on Friday and then they went through the values in that order. I think it's alphabetized, actually. So those are the values we want to go through. But now we need one more thing right here. Brian, we need to pick a what. We're super close. Brian, we need to pick a what now. We're super close. We're really close. Few more steps away. We're starting to see it. Those are the values we want to go through. We want to go through Friday, Saturday, Sunday. So when it runs the first time, this becomes Friday, then it becomes Saturday, then it becomes Sunday, wait, this right here, right? This should probably become a what? A variable, right? So let's call it W day. And then up here, this becomes W day. Now, I'm just putting a print around this to show you the answer. I'm trying to show you that it is working. So that does work, right? But we haven't stored it into anything. I'm just showing that it shows the answers. Like, that's not what we want to do yet. It's just storing the answer. Here's the really cool thing. Let's go here and create a vector. And let's call this answer 3, right? And so we are going to store into position on answer 3 and call W day. Now, what's really interesting about this is the following. Storing into position W day actually creates a named vector because W day has a name to it. So the first time it stores, it actually creates position Friday, then it creates position Saturday, then it creates position Sunday, position Thursday. So you actually see a named vector right here because when we stored this into position W day in answer 3, it's going to name the position the name of the weekday. So it says store into position Friday, but there is no position Friday, so it's going to create position Friday as position 1. Store into position Saturday, but there is no position Saturday, so it creates Saturday as position 2. Does that make sense, Ella? That's kind of the neat part at the end of this, to be like, okay, let's store it into something. Let's create a space for it to store. You always have to have some space to store in. You can't store into answer 3 if it doesn't exist. Like, watch this. Store into answer 4, and it says, nope, I don't know where answer 4 is at. So you have to create this. This is called initializing a vector, or just, I call it creating a space for it to exist. Like, if you say store here, it has to exist for you to store into it. So that's got it. Or how did this one? This one was maybe a medium difficulty, I'd say. Once again, these take practice. We haven't even covered this. We'll be covering it tomorrow. I can see how these are a little tricky. So don't worry. That's got it. Let's go back here to the main screen. Are people working on a specific one of these? I can do number 4 next. But which ones are people working on? Let me know. Activity 2. Oh, I missed an I in activity. Activity 2, for loops. Question 4. Are people working on any specific one of these? Let me ask you right now. We can get through quite a few more. Which ones are people working on? What questions do you have? Let me know. I ran out of coffee forever ago. One last drop. Power through right here. Let's take a look. Number 4. What's number 4 cover? For loops over category. It's very similar. It's very similar. Number 4 is super similar. And there's a lot of tips for how to do it. Okay. So I got some number 4 right here. But put those questions in the chat if you have it. And let's see if we can knock out number 4. Let's do this. For loop over categories. The data frame product, which once again, make sure you've loaded in the data frame at the start of this, has different, whether or not things were a success, the outcomes are a level of success and fail. And there's categories A, B, C, D. Write a for loop that produces a vector called prob failure. So you know what we should probably do? What could we maybe do right now, because we're going to be using this vector? So who has an idea, like if we're going to create this vector, so it says we need to create this vector. So what should we probably do if we're going to be storing into it? Ubot's talking away. So what could we do right here? And then we'll talk about the theory behind this. The theory is the most important part. Basically, these are logic. Boom. Ella right there, more points. You got it. Prob failure, store into blank vector 0. So we have to find the probability of failure for all products. So what do you think we should do first? What do you think what do you think we should do first right here? Like, we're going to do it for every product, but what do you think we should do first right here? And I'll get the ball rolling on that. What do you think we should do first? What do you think we should do first? Might be some really easy ways to solve this. Like, I might try to do it without a subset. I think I might do it without a subset this time. I'm gonna do a different type of solve on it. So what should we do right now? I'm gonna do a totally different solve than I've ever done on this one, just for fun. I was thinking of a different way to solve it. What should we do? Because we want to find it for every product. So what should we maybe do first? So we need to find this for product A, product B, product C, product D. So what should we maybe do first? What should we maybe do first? So we have to do it for product A, B, C, D. Maybe we should just start by doing it what? We got to do it for A, then B, then C, then D. So find one product. Exactly, Ella. Fine, let's just do it for one. So you know what I'm going to do right here? I'm going to go to table. Let's go product. My product data set. What? Is it department? Oh, I'm going to need to load product. Oh, there we go. Okay, now we can do it. Okay. So we have the outcome and product category. Cool. Now we have a table. Is this... There's a way to get margins. Let me look at table real quick. If you're ever wondering how to use a function, you can always do question mark function, and it'll tell you how to use the function. I am looking for, I thought there was a thing that gives you margins on it. Use NA, depress, row names. I thought for certain there was a margin thing. I know I've seen it. Well, I can do it without it. I can make it appear. Okay. So to find, I swear I've seen it. I've done it. Just can't remember the code right now. Could Google it, but we'll do it the hard way. Okay. Can you just tell me, we're looking at the probability of what? Success or failure? Right for the probability, prob failure. It's called prob failure. Okay. So how many product A's were there? How many product A's were there? How many product A's were there? And what we could do is we could say tab, just store the table. How many product A's were there? How many product A's were there? So how many product A's are there? Just total how many product A's? 635, exactly. So tab 1, that's rows and columns, plus tab 2, 1. Does that make sense what I did right there? I just counted those up. So this is the total amount of product A. So let's say total A. Does that make sense? That's the total amount of A. So there's the total amount of A right there. And then we need the amount of failures, which is actually just this one right here. So let's say fail A. And prob failure for the first product is fail A over, let's just say fail. Total fail, because I'm going to use these for the general purpose. There we go. And that's the probability of failure. Man, product A did not do well. Hal, Connor, and Ella, great work. Does this make sense what I've done? I'm using the table, pulling the positions in the table, and just storing position like rows and columns. I'm saying, okay, I need to take row 1, column 1, which is this. That's what that is. Plus this, which is this. And now I want you to think about this. When we run this, that won't be needed. We need to create that right there. That's our table. And then when I run this, if I were to change this to product B, I would just be changing my what? So be careful. This is where people will probably make errors on this. If I'm going to change this to product B, I should just change my what. And look at what would change right here, and we do the same sort of algorithmic math. So if I'm doing this for product B, I would just change my what. If I'm doing this for product B, I would just change my what. If I'm doing this for product B, I would just change my what. If I'm doing this for product B, I would just change my what. So think about product B versus the column, exactly. So that means for product B, this would become 2, 2, 2, 2, run, run, run. What does this code look like that I've probably created right here? I'm actually making the vector as we do this. Now I'm changing it to 4. This code right here looks like I've probably created the what, because it's the code that just repeats. I've probably just created the what for myself. This code right here probably looks like we have created a what? Control I, reformats code. So this looks like I've just created the skeleton. Do you see the placeholder? The placeholder is going to be this, and let's call it column. Probably a good name for this is the column we're going through, and it can be any name. Usually we choose something that makes sense, and that'll be the placeholder, and then what's the vector? And after we do this, we've created it. So what'll be the vector that went through? Now, if you watch, you saw the vector as I ran it down here. What vector did my columns go through? Like what vector am I going to tell it to go through? I'm going to tell it to go through, and there's many other ways to do this. I didn't call the product name. I could have subsetted product like we did in the last one. So you could say, well, could you subset the product and then find for that product? You could. There's many different ways to do this. I could do an alternative solve on it, but I don't know. I just saw it this way. I was like, why don't we do a table? And then just take the information from the table to get it. We could have probably also just had the table do percentages for us. There's quicker ways without for loops too. But it's good to practice and know how to do it, and be like, oh, because then you understand the syntax of a for loop a lot better. What vector will this go through? When the code runs, column needs to become this, and then it needs to become this, and then it needs to become this, and then it needs to become this. And you can see the code happening right here. You can see what column is changing through. So now wherever column is at, it needs to go through those values. What vector of values will column go through? So column will start at the what column of the table and then it'll run the first time and do that, the second time and do that, the third time and do that, the fourth time and do this. What values will column take on as the code runs? As the code runs, column will go from value of this, value of this, value of this. And you can kind of see the code right there that I was running. You can see the column position, and then you can see it change as the code runs, as I was doing it without utilizing the for loop. So what values will we go through? What vector values are we going through? Any ideas? The vector values we're going through is the first column, the second column, the third column, the fourth column. And the quickest way to write that is that right there. Always run your code, make sure it's working. So this right here, and then let's check to see if it created it. And there we go. We could also name it and give it like product A, product B, product C, product D, but that's really good right there. That's a good question and shows other ways of solving it. They might do a totally different way of solving it right here, but lots of ways of doing it. Let's do some question 5 and do more practice. Okay, let's take a look at question 5 right here. See what they want us to do on question 5. 50 activity 2 for loops. Question 5. Let's take a look right here at question number 5. Let's do this. Oh, we got this. So check this out. Write a for loop that goes through the length of empty cars vector and adds together the miles per gallon. Start by creating a place to store the vector. So whenever we say start by creating a place, we're just saying create a blank vector. And let's just call this answer 5. So there is answer 5. Then add together the values to the previous value in a for loop. Okay. That's where it gets a little bit confusing right here. And I think it's got step-by-step on how to do it. So this one doesn't. Ooh, short question. So with this one right here, write a for loop that goes through the length of empty cars. So when we say go through the length, what are we telling you? If we say go through the length, which of this information are we giving you? Going through the length would be information regarding the what? Go back down to the question. If we say go through the length, would that be about the skeleton, the variables, or the vector? If we say go through the length of empty cars, would that be, if we say go through the length, would that be the skeleton we're talking to you about, the variable, or the vector? If we say go through the length, the vector, great job, Ella. And now here's the trick. A lot of people would think you would just go through length of empty cars. Here's the thing. We only need one number in the chat, hint. If you do this, how, and are we doing the... this is super tricky. We actually need number of rows. If you run this right here, super tricky, how many times will your for loop run? The only value right here is 32. Like, for all intents and purposes, this just says 32. How many times will your for loop run if you run this? If you run this code, which is just 32 for all intents and purposes, how many times will your for loop run? Very important. A lot of people make this error. I used to make it all the time. If you run this code as is, how many times will your for loop run? Run once. That's exactly it. Because you're not running it 32 times. The first time you run it, whatever variable is becomes 32. So we actually want to go 1 through the length of 32. Now we get the vector of values. Does that make sense? Ella and Connor, great work. Don't worry. That's the trick. And I'm not joking when I say I used to make that error all the time. Now we have the vector of numbers 1 through 32. So now we just might want to say, I don't know, run number. Sure. It can be called anything. And so now what we're going to do, here's the fun part. We got answer 5C, right? What we want to do is we want to store into answer 5C. Let's go into it and we can overwrite it with, I think this will work. It might not. We'll double check. Answer 5C plus. I know what we're going to do. We're going to initialize it on 0. There we go. We're starting with 0 in there. I get it once you say it. Yeah, no, don't worry. This is exactly it. Don't worry. Even if you say I don't know, that's fine. I try to drop as many hints as I can, but you're doing perfect, Ella. Like, I know I'm throwing out crazy points, but this is exactly, just ask the questions. If you're stuck or you don't know, just say I don't know. That's perfectly fine. And Connor, great work too. So what I'm doing right here is I'm taking what was in answer 5C, overwriting answer 5C with answer 5C plus empty cars. So sad, guys. What is in the first position? Well, the first time it runs. I think this is the code. I should have showed it better. I think that's it. No, all we're literally doing. I think I wrote this question. All we're doing is that. It's a very ridiculous task, but it's to see if you can do it. Like, if you can do this, you might have to utilize it for other things. Everything we're doing right here goes into, you never know when you're going to have to know how to utilize something or use it, because we've just been making, I'll show this right here. We worked on an app, a student and I, we worked on it together, kind of like he created parts, I created parts. It's just like we kept going back and forth, but you never know what you're going to have to utilize. So we created this click rack. You might have already seen it today. And when you click the start timer, it goes. I got to mute it after. I love it. I love it. So this is all created with our code. We got to make sure we don't play too much and get copyright claimed on our video. But it plays final countdown. And then, so you can actually play the clicker game. Oh, I actually played Final Countdown. Oh my gosh, I should have. Okay, maybe the thing, 45 times. I've broken 50 a few times. Watch the Statue 1 class, I broke 50. And then you can see your clicks down there. But it does a little psychedelic Final Countdown for you right there, doing random rainbow colors. Got the rainbow just flashing for you right there, random rainbow colors. One is unexpected error. James, can you send me your code on the Discord? I can debug it for you. But I just love watching this rainbow. We could just give you a rainbow screensaver from this. So we could generate random rainbow screensavers and just call this random. You can open it in a browser. You can full screen that browser. So I could just create a random, it might be a little too psychedelic, but all this right here, it sounds like you're missing a closure, but send me your code if you want. And all this code right here that we worked on together, I worked on part of it. He worked on part of it. I did the rainbow effect. He got the background color change. He helped find the timer, I think, and then we put in the timer, and all this different code right here is based on what we're learning. So you can see a bunch of it looks pretty crazy. It looks like a lot. There's where the rainbow palette is created from, but a lot of fun stuff right there. And I don't know. I have a lot of fun creating little things like this, and we're using different libraries and all this great stuff. So that's 475. Get to have a lot of fun. I love it. I love for loop mega practice. We probably won't get through all this. James, did you send me the code on the Discord? Let me see here. I might have too many messages. Let me see. James. Wait, that's a J. Nope, not James. Send me your code if you can, and we'll check out number 6 right here. Oh no, I like that little lab. We're not getting copyright claimed. All my videos get copyright claimed today. I don't know how there's a plus button on the Discord. There's a plus button. And are you on the Discord? If you click my name, you can just click the plus button and drag drop code, and it'll send me the code. Discord's so easy to send and receive files and everything. You just like go to your messaging, you just drop it in, say, here's the code. So it's really great for that. We'll start this up right here. And James, if you can't find out, you can also email me at bstevens@utk.edu, and I can take a look at it, and I can find out what's going on with the code. If you don't mind, if you want, I can debug it on screen for you. So thank you, James, for being here. We'll make James a mod. Why not? Let's check this out. Let's go back over here. We got time for a few more. This is a humongous practice. What the heck? That one says 42 minutes. Can't be 42. Has to be 52. I must have took a typo down. Typos, no. Activity 2. For loops. Question 6. If you have a specific one you want to know, let me know. But let's go check out number 6. The function f, defined in the following chunk, takes an argument of x, a single value, and runs this blah, 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 blah on it. Imagine that the value of f gives the cost of some manufacturing process. Okay, cool. So this is just some sort of thing that our company uses to figure out the cost of some sort of manufacturing thing. Is desired to minimize cost and thus define the value of x that gives the smallest possible value of f. The choices we have for x are the values in the sequence 474 that start at 0 and end at 1. Oh, a sequence of length. Okay, cool. Probably what I want to do right here. Let's create the sequence. Does anyone know how to create this sequence right here? Let's just call sequence. Store it into a sequence. And what should we do? So I'd probably just create this. Like if I see, it says we have a sequence of values that start at 0 and end at 1, and there's 474 of them. So it says it starts at this. So who knows what we could type right here? It says it starts at 0, it ends at 1, and there's 474 of them. So it starts at 0, it ends at 1, there's 474 of them. How do we code that? It starts at 0, it ends at 1. So it's from 0. It goes to 1, and it has that many objects in it. So we have to give this arguments somehow. And whenever you're confused, always remember. Exactly. So let's say from equals 0 to equals 1, length equals 474. And then always view what you create. And there we go right there. There are 474 elements with that right there. Initialize a vector called cost. So cost storing to blank vector. Then write a for loop to define the ith element of cost as the value of f. Okay, cool. Awesome. Well, it's telling you how to do it. Okay, so do we have the function f down here? Okay. So it seems like a lot of work. Seems crazy. It's just gonna, whatever's put into x, it's gonna run that function on it. And we want to know what's going to happen as we go from the values, and we can see right here. So it looks like the minimum value should be close, or where's the minimum value at? I can kind of show you, but where do you think the minimum value is going to be at? It's really cool that R can do all these plots and stuff pretty quickly. Method brand. There we go. There it is right there. It's right there. So we need to find that, right? So we need to find that value. How are we going to do that? We need to generate these values right here. So let's go ahead and try to generate these values and return them to our company and say, okay, we have ways of finding this. I've never even really used the optimum function. Pretty interesting. I don't know what method Brent is, but it's doing it over this boundary using the function f and parameter. I don't even know what it's doing right there. I've never used that function. Pretty interesting function. I've seen it, but I haven't used it. Okay. What we want to do is we just want to take function f and input a value. Does this make sense what function f does? Who's with me on what function f does? Function f takes a value and then runs that function on it. So we created what's called a custom user function in the environment. Like if I want to say a function right here, and if I call it add two things, I can create my own custom user function where I add two things, and I just go sum of vector x and y, and then I create my custom function, and then I go to add two things. I should probably put return on this. And then I run it by going 10 and 2, and then I get, or there you go. So that's what a custom function is. It allows you to define a function that does certain things and takes inputs. My function takes two inputs and then returns what those two things are added up together. This is I don't usually use the defining a function with the x. I usually use it this way, but all this is a custom function called f. Like I created my own custom function right here. This is a custom function. That's a custom function. And we just need to know that this is a function where it puts x in for these values. Like whatever's right here gets assigned x. So what's really interesting is this problem seems crazy difficult, but all we're going to do is change the value of what? All we're going to do is change the value of what? All we're going to do is change the value of what? All we need to do when we run this is going to change the value of what? I'll go grab create a spot for it. Cost. All we're going to do is just change the value of x. That's it. So if I go right here and I go to the first thing in my sequence, remember that SEQ I made earlier? I think that's right? Oh, we don't want to do that. We want to store the first position. So now, here's my sequence of numbers, and I want the first number. And now I just stored the first cost. Then I want to go to the second number in my sequence and store the second cost. What did we just create? Seems really complicated, but we just created the what? We just created the what right there. What did we just create? Because now I could go to the third thing in my sequence, or well, third thing in the sequence, sort of third spot of cost. I just created my what. If you've been practicing reviewing, you're like, oh, that's the thing. He's just looping through it. He's just doing it multiple times. I just created my skeleton. Connor, great job. James, Connor, LX and work. That's the skeleton. We just created the code that's going to repeat. So tell me, 3 is going to be the what? 3 is the thing that changes. So that probably needs a placeholder. So that'll become the what? Because every time I run this, 3 goes, it'll go to 4 next time, then it'll go to 5, then it'll go to 6, then it'll go to 7. Shreya, great to see you here. 3 will go to 4, then 5, then 6, then 7, then 8, then 9, then 10, then 11, then 12, and all the way up to 474. That's the what? It's the variable. So let's just call this element for which value we're doing, like the element, the first element, the second element, the third. And so we just call this element because that has to change. And can anyone type mathematically for me the sequence of numbers I'm going through? Just think about how long my sequence was. You could do it by that. But, I mean, I would code it this way. Since I already know the length of the sequence, I'm just going to input that. So what is the vector of numbers it needs to go through? What is the vector of numbers it needs to go through? What is the vector of numbers it needs to go through? So it's going to go 1, then 2, then 3, then 4, and then all the way up to 474. That's what it's doing. The first time it runs, it's going to store into it 1, then run the code, then store into it 2, then run the code, then store into 3, then run the code, then store into 4, then run the code. Close, Ella, so close. I think you're thinking about the second problem. This one doesn't have the trick. So Ella, you're so close. Don't worry. I think you're thinking about the second problem where we indexed it a little bit differently. Yep. Both you, great job right there, 100 points. This one is going to store into the first position, then do that. The reason this second one, I've got the volumes turned down. The reason that second problem we did is because I guess we could have changed it. We could have done a 1+ on the other spot. But this is going to then store into the first position the first time it runs and use the first element of the sequence to run the function on it. Does that make sense? Go to the sequence, get the first thing, perform function F, store that into cost position 1. Element becomes 2. Go to the second element of the sequence, run function F on it, store into it cost position 2. Element becomes 3. Is this making sense as I talk through the for loop? Go to sequence, get position 3, run function F on it, and then store into cost position 3. And let's run it. And there we go right there. And let's go look at our cost vector. There's the cost vector. And if we've done it right, the min of the cost vector should be 2.5. Oh, well, that's the position. If we go to... Oh, yeah, so that's the minimum cost. And let's do which min. Well, this will be the position. Position 119. So sequence, position 119. There it is. It looks like it might have had a finer thing on it. Yeah, so that's the position of the thing in the sequence. It was position 119, its value 989, and this is confirmed 98945 and 98945. There it is right there, 98945. It's 20.25. It's the, I don't understand what that is. I do understand what this is. That is the value by which we have the minimum right there. So, but our sequence just didn't have enough values in it. Probably we would hit it right on the dot if we had just changed our length of our sequence. Don't do this, but now we will get that value by virtue of us having it. And which min, what did I do? Oh, I need to reinitialize my vector because my vector still had the other information in it. So I'm reinitializing that vector, and now the which min is 26. And I could just take which min right here and drop that right here, and we'll get the 0.25. Oh, weird. Oh, interesting. Oh, because of the way it works with numbers, we didn't exactly get a sequence of, you look at the sequence, it's not whole numbers again. That's fine. But yeah, do we need 101? Gosh, I'm so bad at making sequences. Okay, now we should get it right on the dot. And I don't think we need to initialize that because we're making a longer vector. And there we go right there. There it is. But now it's converged to the output. And that's really interesting with estimations and stuff, how that can work. But that's a pretty good problem, pretty tricky. Let's do like 1 or 2 more. What are people thinking? Let me know if you have questions right now. This has a lot of practice. What are people's thoughts? What are people thinking? Who feels a little bit better about for loops right now? Who's like, I understand it a little bit better because we're going to be covering this week and how they work. Remember the skeleton, the variable, the vector. We need to know what all those things mean. Skeleton, variable, vector. Skeleton, variable, vector. If you understand those things, then it's just like talking through in practice. You just have to keep making them. You have to be like, okay, I got to make another one. Got to practice how it works. Got to ask myself this question. Not at all. That's all right. Ella, great. Ella, 100 points. Thank you for saying that. That means we got practice. That means we got lecture. We got a lot of work to do. And that's a great answer. Let's do one more here. Let's see. Might be able to come up with an easier one. Basic for loop. This is basic. This activity has 14 questions. Let's see. I actually solved this on a plane going to see my fiance. Oh, the sequence of flips questions. I like that one. Let's write our own for loop. And then we might do some more practice. I might do another activity, like call this part 1. Let's do our own for loop. You ready? We're going to practice. And this is the most important stuff. I think some people might be like, write our own for loop. Our own for loop. This is where you really learn it by just creating your own and coming with your own ideas. Let's try this. Okay. So if we're going to create a for loop, for loops are used when you have a task that is going to be very what? For loops are created for when we have a task that is very, very this. Why would we make a for loop? Our task is very, very what? Like think about everything we've just been doing. Why do we have for loops? Why make a for loop if your task is very this? Repetitive. Matthew, great answer. We're throwing Matthew mods. Why not? Exactly, Matthew, 50 points in the chat. If your task is very, very repetitive, you'd make a for loop. So we have to think of a repetitive task right here. And a lot of things like web scraping or stuff like that are great for for loops. Like if you have to scrape 100 web pages, perfect for a for loop. So let's go up here. Oh, that's such a fun thing. Oh, we should do this one. I think if you do this, if you run this is like cracking a safe. I think it says false. Oh, do we not have it? Oh, it's a number. Let's crack this safe. The number is not 1. This is such a cool... Well, imagine we're sitting here trying to open this safe. Could you imagine a kid trying to do this? But we're adults. We're going to crack this safe a lot better. We got that in the global environment. We could crack this safe. Like, could we... Like, do you notice what I'm doing? This repetitive task? Do you see it? It's mad about the graphics again. I hope the number isn't too low, but... I mean, I'm just going here. I'm just typing in numbers. Don't try to do this. Don't break into stuff. We're going to crack this safe, though. So, do you see the repetitive task? Funny enough, this is a very simple problem with a for loop. What do you think I should do? What does it look like I'm doing by just repeating this thing? I probably have a what right here. So I'm just constantly redoing this and changing its value myself. But the code can do that for me, right? So what does this look like it might be if it's just the thing that repeats? And this is what we need to know like that. Like, oh, that's the thing that just repeats a whole bunch of times. That's your what. So we've been practicing this word a lot today. That's the code that repeats. Oh, nice, James. So that's the thing that's just going to repeat, and we're just going to change something inside of it. So that should be the what right there. Let's see if... What should that be if that's the thing? The skeleton, right? So what am I going to type right now? I'm going to ask you every question. There's a simple one. To crack this code, we can do it pretty quickly. I'll just ask the questions. What should I type to get my for loop going? Now, don't type too much. Just type 3 letters. Every time we write a for loop, make sure our life's really easy. What do you think we should type to get the code going? What should we do? Just 3 letters to start a for loop. And then it'll do the snippet, which is so much easier. What should we do? 4, F-O-R. Great job, Ella, right there. There's the snippet, 100 points right there. And let's take this code and drop it in here to the skeleton. Now, we got a problem, though. One, our code really doesn't work. It says no. It's like, you're not doing this right. Okay. So we should probably... what do you want to change first? I'm going to let you guys drive on this one. What should we change first? What should we change first? Great job, James, right there. What should we change first? What do you want me to change? We got to crack this code. If I know Petrie, I forget the answer. Petrie. Okay, good. Delete. What should we change? Thoughts? What should we change? I mean, we got some stuff changed up there. You can tell me what to change it to. I just want to try a whole bunch of numbers. I just want to go through a sequence of numbers and try them, but I need it to somehow manipulate the code down there. And then we'll talk about what happens as we change this. This doesn't work right now. Like this doesn't like it. It's not working. Broken. So I probably need to put things into there. I could change 2 things and get it running, but I might change 3. What should we do? Define the variable. So let's just call this code. How about that? Okay, so where should code go? Code is the placeholder. Great job, Matthew, right there. So code is the placeholder of what will change. I think Ella's pointing out this will then go to here, right? We actually could have called it variable. That's what I was kind of saying. Well, I don't have to change that. Okay, so now when it runs, whatever is in vector will become code. So we should probably do what now? I'm letting you guys drive. You got this. So what should we do now? Because this still won't run. Let's try it. Still doesn't run. What should we do? We're almost there. Create a vector, exactly. Tell me I'm letting you guys do this. Okay, let's create a vector. Let's do that. What vector should we create? It's a numeric answer, I believe, for this. So what should be our numeric what should be our numeric thing right here? I might even make a harder version of this really quick. What should be our numeric thing right here? I'm gonna do a harder version. Sequence vector. So what should we make? What should we make? You tell me what to write right there. Like, tell me the sequence vector to write. And then I'm gonna do a harder version of this, like create something. 1 through 55. Oh, we go, James, you got it. 100 points, James. Let's go more crazy than that. 1 through 55. Okay, so we don't see anything because the code's just doing itself in the back, doing like its own thing. So we could do 1 through 55. What other thoughts should we have? Oh, we could do that. Oh, I think it's a whole number is the answer, James, right there. So that will work. That'll create a sequence from 1 to 5 by the increments of that. But so now, how could we see if the answer was right? How could we see if we got the right answer? So we're super close. Like, how could we see if we got the right answer? Think about what we did in the previous problems. Like, any ideas on how we could see? There's multiple ways of doing this. Maybe we want to store it, right? Let's see if our answers are right. How could we store this? We're almost there. We got this. This is actually one of the problems, but it's a pretty fun one, I think. We need to look at this output. We need to be like, let's store this and look at it. So let's go right here and say worked, and then let's store into position code because that'll store into position 1. Now here's the thing though, why did that not run? Why did that not run? Why did that not run? You're exactly right, Ella. Why did that not run? So why did that not run? I'm going to do one more quick example. Why did that not run? Ella says we need to create or initialize the vector. Ella, that is a huge error that you caught. Great job, 100 points right there. And now, how could we figure out if one of them was true? How could we figure out the position of what was true? Because we could look at the vector, and how could we figure out the position of the true in the vector? So that's the vector, and if it worked, how could we figure out the position of the true? Like, which one is true? How could we figure out which one is true? How would we figure out which one of those is true? Maybe none of them are true. Maybe we'll find out. How can we figure out which one of those are true? So how would we figure out which, like the position, which one is true? If there is. If there are multiples. How do we know which one is true? Those are positions. But how, if we have a logical vector, how can we figure out which ones are true? Like the positions of what are true. So like if I have a vector of like true, true, false, That and all we need, and so Al, I think you're on the right track. So actually, you don't need the what you have right here would kind of work. Watch this. You ready? Which worked? No, there's nothing that worked. What do you think I should do now? We're almost there. We almost got this. We're right about there. There's just one more thing. I think the last thing. None of those numbers worked. So what do you think we should do? We tried 55 numbers. What do you think we should do now? What do you think we should do now? Thoughts on what we should do now? Make the vector. Okay, so what should I do? I'd agree. I agree with that. I think it's a good idea. You got it. That's what I would do. So what should I do? You're in the driver's seat. I mean, I may have like turned the wheel a little bit once. But what should I do? Oh, I like that right there. No way. There, we found it. We just need that extra 0. There's the answer. We just cracked the safe. How long did it take to do 100,000 tries of that? Like that. I actually tell you the answer of it. Start systime. You can find the time here and then take systime minus start. This is actually how we do the app. If you saw my app a moment ago, so the amount of time it takes to run this code, well, I guess technically we should put this at the start. This code takes less than a fifth of a second, or yeah, less than a fifth of a second. Probably might even be quicker now. Yeah, you can see how long it takes. You could loop that and see how long it takes on average. But it takes about 0.2 seconds to run 100,000 values, and the computer just does it like that. So we just went through 100,000 values and found out the answer to the code is 59,148. What I'm very interested in is, I'm going to create a secret function right here, and then this will be our last problem. Let's say Brian's secret word. Brian, can you guess it? What is the word of the day? Word of the day guess. And this is cool because so I have to create a function. Okay, guess. Word. If can't tell you it. Okay. Let me see if this works. Okay. Okay, got it. You can't see it. Okay, good. Okay. So what I have right here, I should do lowercase only. There we go. Makes life easier. Okay, cool. Can't see it. Okay, good. What I have right here is a guessing game, and it's a password. So you have to figure out the password right here, and it's only 3-letter words like sky. And sky is not the 3-letter word that's, I hope, wait, does it? Okay, good. You can't see it, I don't think. Does anyone have a guess of what the passcode is? Does anyone have a guess of what the passcode is? What do you think it might be? What is the passcode? We got like 10 more minutes, I think. What is the passcode? It's only 3-letter words. What is the passcode? Well, people think that over. I'm just going to go here to go alphabet. And I'm going to store a vector in. Oh, well, what am I doing? What am I doing? I've already got the alphabet. What am I doing? There's the alphabet. We already got a letters vector. That might come in use here in a moment. So what is your guess? Any guesses? I'll throw 1,000 points if you guess the answer. I'll throw 10,000. We'll just break the system. I don't think I showed it. Am I that predictable? I'm not even going to give any hints. We'll find the word here in a moment. I'll crack this safe code here in a moment. It's a 3-letter word. And we can probably find out pretty quickly with code. We could also look at Untitled 34. 10,000 points if you guys a dog. That's worth 200 points. Good guess. Good guess. I don't want to drop hints, but good guess. Dog. Is it dog? False. It's not dog. So how about this? If only there was a way to generate 3-letter words, right? So we probably need a code to generate 3-letter words. So let's try this. And there's a lot of ways we could do this. I'll do it the for loop way, maybe. Let's generate 100,000 3-letter words. Does that make sense, Ella, what I'm doing? I'm going to generate 100,000 3-letter words. So let's do that. What we need to do is we need to first generate one 3-letter word. To generate one 3-letter word, we want to go here to sample from letters 1 letter. Then we need to append to this vector, because we're going to make a vector, 3 letters. Does that make sense? We have created, and I'll zoom out a little bit, we are creating one random 3-letter word. Aw. Was it aw? Now, a problem we have right here is this is not, it says false, it's not aw. Gotta watch. I don't think we're anything too crazy. This is just randomness. If anything shows up, it's just random. I can't control. This is all random 3-letter words, so I'm gonna not generate too many more random ones. And then we're gonna go right here and go to collapse. I just learned this recently and I love it. There we go. PFE. It's a random 3-letter word. Is it this? Right here. It's not. But how about this? Let's go here to words and let's make our first word. I told you I'd do it and I really did it on accident. There we go. So now we just created our first word, OTX. So I said I want to create 100,000 words, right? What did we just create right here? What did we just create with this right here? I created one word, but now I want to create 100,000 words. So what did I just create? I just created my one. So if I have this right here, the skeleton. So let's go right here and go for and create, let's say number, and then number 1 through, and there are 100,000 3-letter words. So now we got it. Now we need to go here and go to for, and let's say worked. We're going to do the same thing we did like for the last one. We could literally, I don't know where I deleted it. I can go to worked and store in the value of true and false into it. We're going to take my guess function right here, and we're going to literally do the same exact work we did last time, where we take the word in position 1 and see if it works, and store if it worked into the worked vector. And we need to go from, we're taking that. We're going to take right here value, and we'll put value right there and go through 1 through 1, 2, 3. Oh, did I do 1 million? 100,000. 1, 2, 3. And that should do it. Did it work? Oh, did it do it that quick? No way. 5. Oh my gosh. It found my word 5 times. So there were 5 times it worked. I didn't need to generate 100,000 3-letter words. It worked 5 times. Which gives us the positions. These are the positions. It should work. We're going to see. Bun. For the bunnies. The word was bun. And we just generated 100,000 3-letter words to look through possible combinations of 3-letter words. Probably could do it for a 4 and 5-letter combination. Just the you're doing 26 to the 3rd power. The amount of 3-letter words that exist are only 17,000. So I guess we got about the right amount of times it could have occurred. If we'd done 4-letter words, might need to generate 500,000. Problem is when you get to 5-letter words, this is why like passwords don't want you to use like 3-letter words. Literally goes to the safety of passwords right here, which is kind of a neat topic to end on. When you get to a 6-letter word or a 7-letter word, just think about with 7-letter combinations, especially if you include extra characters, like as soon as you get to include capital letters is going to double the amount of characters, include punctuation. include something you're getting to like ridiculous combinations of stuff. Like you have to have a 7-letter word that has capitalization in it somewhere, usually the first letter for most people. Not saying, but password security is very important. So the really, really secure passwords are going to randomly do it throughout, but then a lot of people will put things in certain places, making it more predictable. But if you go by complete randomness, there are all these combinations right here of possible with 65 possible uppercase, lowercase, or special characters with 7 required. And if you raise it to 12, it gets ridiculous. Like that's why, you know, a 4-letter word as your password could be easily destroyed by a computer, but also things are pretty good at like not allowing you to do multiple attempts. Like they're going to have security to not allow someone to just like, you know, go through these combinations, because we were able to find the password 5 times. So pretty neat little example. And I created this little function over here that was a custom function where you just had to guess the word, and it's just a custom guess. So you enter in the word. If the word is bun, it tells you true. If the word is not bun, it tells you false. And that's how we were able to then crack this code and create it. Ella, how's it looking? Did that make sense? Kind of I don't know. I like the examples like this, trying to think of like a guessing game. We can make an app for this. I don't know. Fun to make like Hangman or something like that'd be pretty neat. I wonder. I don't know. I want to make Hangman now, but I'm gonna head off here. We've done a lot of good work today, a lot of good practice. We might do an activity later this week or a little more help on this. This is a tougher activity, a lot of work, a lot of practice. Class is gonna be pretty important tomorrow. But with that, I want to say a big thank you to everybody. To Ella and to Matthew and James. Here's the biggest thing though. If you're stuck on this stuff, please message on the Discord. Please ask for help. If you're stuck, ask for help as soon as you're stuck. Just be like, hey Brian, I got a question. Following along is okay, but I'm just not confident. Yeah, no, you're doing fine. Doing fine. This stuff is tough. Anyone who feels like they totally understand it probably doesn't even need our classes. So if you are like, okay, I'm getting the ball rolling on this, you're on the right track. Even I make errors. And truthfully, if you had asked me to do this like 3-4 years ago, I probably would have had trouble. It just becomes second nature. Like even I said like this whole collapse thing, which I tried to do stuff like this a year or 2 ago and I was having problems. Just needed one more argument. Someone could have looked at it and said, oh, you should just collapse that. And I said, what does that do? They say it just brings everything together into one word. And I say, oh my gosh, that'd be such an amazing little argument to put in there. So it's just about the practice, and you start to learn more of the language as you do it. Even I'm learning new things every day. Well, that's got it. Puppet Shark, you want to say bye to everyone? That's a tiny Puppet Shark. That's regular Puppet Shark. With that, we'll be back. I'll see you in class tomorrow. If you have questions, let us know. See you then. Bye, everybody.